second part of it. You can find the first part of the episode about registry pattern on the NBcast, and here we'll focus on how Hanami leverages this pattern and what benefits it gives us. Also, if you want to know more about dependency injection and the registry pattern, we have a few episodes around this topic already. Make sure to check them out by clicking on the tag button. Let's start then. I ported a tiny Todo app using to Hanami. It has been written as a plain Ruby application, and it's not written using the Hanami way. Hanami is a very skinny framework, and while you usually will leverage the advantage of a default file structure, writing a simple Hanami app is very straightforward, and you can fit it all in a single file if you wish. One challenge it faces is the complex web of dependency management, where certain objects are frequently that get passed around to multiple components. Let's take, for example, the database. We have our main object, the Todo app. It has an instance creation method which returns a new instance of the application, and it receives the database as an argument. Then, on the initializer, it assigns this database instance. Subsequently, methods like TodoTasks and DoneTask create a new task list object, which also receives the database instance on its load method. We've passed the database to two classes so far. As I said before, this is a tiny app, and by that, I mean that it's an application that implements, at its core, only 4 classes. At this rate, if we keep growing it, we'll end up passing the database to dozens of objects. This dependency management problem can get very complex very quickly. But Hanami provides us with a solution, dependency injection using dry system. To use the dry system integration, we first need to create a provider under the config providers directory. Since on the Todo app class we access the database through the DB attribute reader, we'll call our provider with the same name. Let's create the dbrb file. Inside this file, we register a new provider called db and we pass it a block. Then we call the start method, and on its block we create the database instance. Finally, we register the db provider passing in our MongoDB object. And that's it. We've created our first provider. There is a bit more to say about providers, but we'll leave it for a later example. What we've done here is create a long-lived object that we will be able to recall across our application. Let's use our new provider object in our Todo app. The first thing we need to do is to include the depths module passing to the brackets the dependencies we want to inject as strings. We can now remove the initializer and the DB attribute reader since they will be automatically written for us. We also need to remove the arguments and parameters in our instance creation method. And on our TodoTask and DoneTask method, we can keep using the DB method to retrieve the database connection. This is due to the attribute reader that dry system wrote for us. Lastly, we'll remove the DB arguments to all the calls to Todo app load in our actions and our specs. Now we can check if our application still works, which it does. Let's now do the same thing with the task list class. In this class, we receive the DB argument on the load class method, so we'll remove it and also take out the DB parameter on the call to new. While we were near the top of the file, we'll include the depths module with the DB dependency. This means that we have to remove the argument on the initializer along with the instance variable assignment, and remove the DB argument from the TodoTasks and DoneTasks method on our Todo app. Since the Todo app class is the entry point to our system, we don't need to change anything else to try out our application. Let's do it by running the specs. There's an argument error in the initializer. What's this about? Well, as I mentioned before, when we include the depths module, it creates an initializer for us, which means that our constructor has been overridden with a new one. In this case, it now has only one parameter, the database, something like this. So if we have a class that already has a constructor, we need to remove it and find a workaround for its functionality. How can we do it? Let's start by analyzing the initialize method. It receives a collection name and then it constructs a collection which gets assigned to the collection instance variable. We can move this functionality into its own method. Let's call it collection name, and we can now remove the initializer. This fixes part of the problem. Now the load method can't send the collection name to the new method, so we'll need to work around this. We'll start by removing the arguments to new and save this new instance in a local variable. Then we set the collection name using the method we just created, and finally we return the new instance. And now all of our specs pass again, and the application works as expected. We've used the database to show how to replace a dependency. Since we are working on an application that uses initializers and instance creation methods not just to assign instance variables directly from the constructor arguments, but also has complex logic in them, aka constructing a collection from its name, injecting dependency results in a complicated process. But what if we want to inject a new dependency, something that we are not using yet, say a logger? The first step, as before, is to create the provider. We'll name it myLogger, because Hanami already ships with one and we don't want any collisions. The previous provider came from inside our lib directory, so there was no need to require it. But since we are using an object that's not automatically loaded, we need to require it. Then we instantiate a new logger object which will log to a file. We configure its log level, and finally we register our new provider, just as we did before. Before going on, remember I've said that there was more to talk about providers. The provider API Hanami provides is designed to separate the preparation steps from the actual implementation of the provider. So let's honor this. We'll create a prepare block where we'll move all the required statements and any other preparation steps we need to perform before we can start writing actual implementation code. And we'll leave this later concern to the start block, the same way as before. Couldn't you write everything inside the second block? Of course you can. But this way, I show you that we get more control over the component registration lifecycle. We can do the most crucial stuff in the prepare block, while doing the time-consuming part of registration only when the component actually starts. Now we can inject our logger, for example, into the Todo app class, and add an info message to any method that performs an action. While you weren't watching, I added a root action and view to read the log message from the log file. So let's add some tasks and play around with them. If we navigate to the log reader path, we can see that the logger has been properly injected into this class with very little extra code. And yes, while I've configured a separate provider for my logger for educational purposes, remember that Hanami has a logger already in place. In a pure Ruby application, dependency management can grow in complexity very quickly as our project gets bigger. But Hanami helps us by incorporating a dry system into its arsenal. By doing so, it provides us with several benefits to simplify our lives. What are those benefits? We can access all our configured components in a ready-to-use state out of the registry. We don't have the need to carry around our setup logic, since it's now encapsulated in the component. On our tests, we can now replace our component in the registry without any need to mock constants, which in my opinion makes tests simpler and more reliable. The number of objects created by our application goes down since we now have a centralized location to grab long-running objects from without the need to create new ones. This has the advantage of reducing the memory used by our app. Finally, a hidden benefit that Dry System provides is thread safety, which is great for working with multi-thread application servers such as Puma. In short, with one gem addition, Hanami manages to give us ease of configuration and a lot of benefits, leveraging the registry pattern implemented on the extreme level. I would love to thank our episode partners and would love to hear if you like this sort of things, as I'd love to collaborate with more people in the future. For that, you can like, share and comment on my episode's discussion thread. We can do more if we do it together. Love you to death, and see you in the next episode.